All right, today we're talking about confidence intervals with proportions. So this is sort of a new estimating topic for us. I'll kind of develop what exactly a confidence interval is, and then how does it have to do with proportions. Well, let's look at a sort of an example of this. Suppose I gave you a jar of pennies. You might see at a county fair they have a jar of gumballs, or one of those things where you're estimating how many things are in this, and they just want you to look at it and sort of take a guess as to what might be in there. Well, this process is sort of one of those methods that would give us a somewhat accurate representation of what's actually in the jar. So we're going to start by defining a couple of terms, starting with point estimate, which is when we take a single statistic based on the sample data to estimate a population parameter. Okay, in other words, I take a measurement of the sample and I use that to estimate what I think the population would be doing. Okay, that's a point estimate when we use the sample proportion or sample mean to estimate the population. The nice thing about a point estimate, they're very easy to calculate, and as we'll see, they're not necessarily the most precise thing out there, simply because when we look at random samples, sometimes we get a lot of variation in our sampling data. So, again, we're developing what this concept is. Okay, so what exactly do we mean when we say confidence interval? It sounds like how strongly do I believe in this, and it's not. That's not really what it is. A confidence interval is an estimate of the unknown population parameter. In other words, it's a series of numerical values that I think the population is somewhere between these two values. The formula is on the surface pretty simple and straightforward. We take the statistic plus or minus the margin of error. Of course, we don't know what margin of error is right now, but the statistic in our case would be the proportion of the sample that we're looking at. So margin of error, let's define what that is. The margin of error is a measure that shows how accurate we believe our estimate to be. So it's not a statement of confidence per se. It's a statement based on some numbers that we actually calculate. So the smaller the margin of error, the more precise our estimate is of the actual population parameter. So a lot of times if you're watching political polls, they'll say, we believe this candidate has 70% of the voter confidence plus or minus 2. That plus or minus 2 is what we're talking about here. The formula for a margin of error, again, pretty straightforward. It's a critical value based on the level of confidence that we want to achieve, and again, we'll get there, times the standard deviation of the statistic. Okay. Now, before we actually look at calculating these things, let's just do a little thought experiment here. I'm going to put some words, some phrases up, and I want you to think about how confident you would be in getting this estimate correct. Okay, so 0 means I have no confidence whatsoever in figuring out the answer to that question. 100 means I'm 100% sure I know the answer to that question. Okay, so somewhere between no confidence and 100% confidence on the following statements. So let's start with guess my age within 10 years. How would you feel you are, how confident are you that you could actually get pretty close within a decade? Okay, what if I lower it to 5 years? Are you more confident or less confident in your ability to estimate? Okay, what if I narrow it down to a year? What happens to your confidence then? Does it get bigger, or are you less confident because I want a more precise estimate on your part? Okay. Now, if that didn't help make sense, let's try another example. Suppose we're going to shoot a basketball at a wading pool, and your job is to make the basket. Okay. So how confident are you that you get a big old kid wading pool in the backyard, and I say, here's a basketball, throw it in. How confident are you that you could actually make the basket in the big giant wading pool? Okay, now let me change the question then. Suppose instead of a wading pool, it's now just a giant trash can. Do you feel like you're less confident because the target is getting smaller? That's kind of what I'm hoping you're getting at here. And then the last level, suppose we're at a carnival and you're at one of those games, you're trying to shoot a basket in the carnival hoop. Do you feel like your confidence gets smaller or larger? Okay, so hopefully you got the sense that when the interval got smaller, your confidence sort of decreased as well. So the statement being, the lower your confidence, the smaller the interval. Okay, so when we have a larger confidence window, that means the interval that we're able to estimate is larger itself. Larger target, larger percent, I believe that we can hit the target. Okay. So that brings us back to this idea of a confidence level. Confidence level is the success rate of the method used to construct the interval. Okay, so it's not, again, it's sort of a misnomer here. When we say confident, that sort of sounds like, well, I believe I'm right 90% of the time. That's not really what we're trying to say with the confidence level. It's that we believe 90% of all samples would be able to estimate this particular number. Okay, so like many things in statistics, when we're asked to interpret, there is a specific phrase that we will associate when asked to interpret a confidence level, and that phrase is, using this method, blank percent of the time the intervals constructed will contain the true population parameter. Okay, so if we construct what's called a 95% confidence level, then I would say that 95% of the time I would expect all samples of this size to contain the true population parameter. Okay. All right, so let's go back to sort of a critical value that we use to figure out margin of error. We introduce a new variable called Zstar. Zstar is a measure of the critical value. This is found from the confidence level that we start off in the problem. This critical value is, in fact, the upper z-score with probability p line to the right under the standard normal curve. Okay, so let me get some pictures up of this. So let's say I want a 90% confidence interval. So if I look at a graph of a standard normal curve, that's where mean of 0, standard deviation of 1, if I'm looking at a 90% confidence level, that means I want the middle 90%. Well, what percent's left for the outer piece? Well, you got 5% above, 5% below. So when we talk about a 90% confidence level, that means there's 5% of our data that's above that particular point. So 95% would be below that value, and so our Z star for 90% is 1.645. Now, in all honesty, write it down. You won't necessarily calculate. In our class, we'll look at very common Z stars, so that 1.645 is a huge value that we need to just make sure we have down. Okay. 95% confidence level. Okay, so another common one that we'll have to figure out. So if you think we're looking at the middle 95, what percent is left for the upper and lower tails? Well, 100 minus 5 is 100 minus 95 is 5%. So you got 5% that has to be shared between the two tails. So that means 2.5% is for the upper tail and 2.5 is for the lower tail. And so if I inverse norm that, I should get a Z star of 1.96 from that. Okay, again, it's a very common value that you will learn to calculate. And then the last common one would be 99% confidence level. Again, so think about that. You got what percent left for both tails, so that's 1. So that means each tail has to share 0.5% or 0.5%. So your upper value would be 0.005, and if you inverse norm that, you get a z-star of 2.576. Okay. Now again, these are very common numbers, so I would just write them down, and that's what we're going to use when we look at critical values. Okay, I did want to make just a quick comment about calculators. So if you're just dying to know uh, which calculator you want to actually physically see the calculator screen. If I go back to our distribution, so go above vars, I want inverse norm, and we want the area is inverse norm. We measure it in terms of less than, so that's 1 minus that 0.005. And in a standard normal curve, the mean is 0, the standard deviation is 1. And so when I hit enter, that's where we're getting that 2.576 from. Okay, so just using inverse norm on that. I would just write down the three values because that's going to come up more often in this course, are those three numbers. Okay, so 1.645, 1.96, and 2.576 are the three main confidence level values.